Good afternoon, everybody. Rosario Maccarrone speaking here. I'm a director and head of skill services at OPIT. I'm here with Professor Alexander Solé. He's teaching a course in computer vision in our Bachelor of Science in Computer Science. Uh, Alex, nice to meet you. Good to have you here.
The pleasure is mine.
And just so a quick start, tell us a bit about your background. What is your academic background, your professional history?
Okay. To start explaining my professional background, I want to explain a bit the background of my family because in terms of computer vision or imagery or images in my family, we have a strong background and a really motivational background because my grandfather was working in a local cinema with the projection machines, and he was responsible for the first 3D projection in my region, and he was like finding like the limit of the time to solve the problems that they have. Then my father was a photographer, and he found the problematic that changed from the analog world to the digital world, and he had to overpass these problems and to adapt to the new era that sometimes you need to use more technology compared to in the past, like it was more manual work, and now you had more technology and more tools. And then my generation, I think the problematic that we have in this field is that the artificial intelligence and the computer visions and how this completely changed the. For example, I remember my father maybe for a wedding album took 3 months to do it manually, and then with, let's say, some editing software, it was like a month or something like that. And now with artificial intelligence, you can edit your photos really fast, and you can do it like in an hours or in a minute. So this was a bit of my passion to see like okay, now we are here, but which is the limit and how we can do like a bit more above. So my background, it's I did computer science that here in Spain is called telecommunication engineering. But my specialization inside the bachelor was image and sound processing. And then I did a master of the same. And then I was working in TU Delft in the Netherlands, basically detecting using the satellites that we have on focusing on there to detect plastic on rivers and sea, to see if with the imagery we can use some artificial intelligence tool to monitorize like every 2 days you have the same image of the same region, but with a little change, to see if that little change is because there is some garbage there, if there is some pollution, if there is no water. So we were working on that. Then I moved uh, to the Basque Country to another research company that we were working more on defense projects and also on autonomous driving, trying to solve problems of driving the vehicles, to detect the pedestrians, to when to stop, when to start anything. And then collaborating with Europol in a project to try to use this artificial intelligence tool to detect some uh, some bad content in the deep web related to pedophilia or something like that you want to detect and find the trace and to see who is the author of this in order to the police take action. So we were using these tools in order to detect and try to also uh, like a really science fiction TV shows that you have an image and you have to say, okay, this image is San Francisco because you can see the reflection of the glass that there is some image or something like that. So we were trying to do more or less like that, based on the data that you have on the image, to see if there is some evidence that you can say, okay, this image is, for example, Portugal or France, and then you can help the police of that country, specific country, to find the suspicious.
Oh, cool. And so, but just yeah, very interesting, Alex. So it's in a way is it runs in your veins. This what images and how images affect uh people, the world, and I can say, well, my impression is that more and more we live in a visual society, of course, where videos and images drive a lot of the things that are happening, trends, even political things. So this idea of what's the limit of how we can handle image, what images mean, both to people and to machines, is very interesting. Um, and so how do you think it's how important do you think is how we are able to use technical tools to understand uh, and to detect how images are generated, what happens in the world, how machines can interact with the world?
Ye- Yeah, I think it's really important to use the tools, because I think I have the philosophy that maybe it's a bit controversial, that if you don't use it, it will be used against you. So I think it needs to be used, and you don't have to be like really conservative and no, I don't want to use that, because let's say, for example, one of the hot topics nowadays, that if artificial intelligence it's art or it's not art. Like, I have seen this many times around the history. Like, for example, when a famous software editing of images was released, everyone was using, oh, but if you use that software, you are not, it's not art. Like, art, it's photography, or like with digital cameras. No, the better it's the analog cameras. But at the end, everybody was using this software editing to edit the images. So uh, it's not. And also I have the philosophy that even if I have a ball, I'm not Leo Messi. So having the tool and having access to the tool, I think it's cool, because it democratizes the society, and you don't need to have like a big lobbies that uh, give you or doesn't give you access to this knowledge. I think everybody should have the knowledge. So I think nowadays, with this era of artificial intelligence, you, even you with your own computer, you can download your model, the weights, and run it in your computer. You don't need to depend of a big industry. But also that you need to use it, and know it, and using the software doesn't make you an artist. But if a good artist know how to use the software, I think he can make I'm not saying like better or worse, but maybe faster. And in terms of this world that everybody wants to go fast and fast, efficiency, it's maybe we have to chill down. I don't know, but the current trend, it's like efficiency. So if you can do your work in half an hour, I don't see the problem of that, because at the end, if I take this artificial intelligence, me, that I'm more engineer than an artist, and I try to do an art, I will not create art. I will create like so fancy stuff, but not so at the end, I have this philosophy, and you have to know how it works, the, like, the corner cases of, okay, in these cases it's not working well, and see how you can overcome, or maybe that part you do it manually or something like that. But you don't have to be against it. I think, like, because otherwise the other people will do it, and we will work faster than you.
Definitely, definitely. But yeah, it's always gonna be a struggle, right? You mentioned a few of the things that you did in your past, research related, how you can use and extrapolate meaning from images. And at the same time, one of the things he mentioned was related to uh, policing in a way, or to try to catch the bad guys, or use images in a way that, so this struggle between the ethical use of this kind of things. I don't want to make this it's a discussion, but it's part of what using easy intelligence or machine learning tools with images brings within the discussion, right?
Yeah, this is one of the main problems of open source nowadays. I think that, yeah, of course, you can do really good things with that. Like, for example, in this case, like we can everybody agree that police must stop pedophilia in deep web. So I think in this case, but also like it can be used to, I don't know, to control the society, or maybe some random hackers access your camera and track whatever you do with your camera or whatever. Like this is a bit of the problematics that we have nowadays, and I really like that. How we have focused the not only my course, all the bachelor in general, that it really focus on the ethics and understanding the ethics, because I think at the end, like you can do always with all innovation, like historically it happens many times. You can do really good things when innovation happen, and you can do really bad things when innovation happen. And I think as a society, I don't know if it has to be us as engineers, or like us pushing the society in that direction, but somehow to force, I don't know, to send the society to into a better society instead to a worse society. And I think nowadays, for example, with the case of fake news, it fakes or so on, you can clearly see that it's current one of the problematics, that it's evolving so fast that it's really hard to counterattack this misinformation, or how as an engineer you must tack.
I mean, it's good enough, or at least it's the first step to pose the question, right? Yeah, to not
Yeah.
hide, just raising the fact that there's underlying potential uh, issues, let's say, with tools. It's the right step, and of course, it's not engineers or computer scientists that could drive the decision of entire societies alone. But as those that knows what the tools can do, I think it's fair enough that we at least pose the questions, that we are aware when we teach our students, and while we move forward, that this is something that needs to be taken into account. Okay, but then, so how do you convey in a way both this and the introduction, the basic tools of computer vision to a student that is learning the, ba- the the basics of computer science, and moving forward towards a bachelor degree? How do you structure your course?
I mean, initially, I like to, in the introductionally, to show a bit of the possible applications and a bit of introduction, like without any mathematics and any, just the concepts, to see like, okay, the applications, a bit of history, because you always need a bit of a background that we come from there and we're moving at that direction, but we need to understand why the decisions have been made in the past. And then one of my favorite parts from the introduction is that I show them one of the, I say like uh, I don't know, professor collection. Like I show them like one of a couple of three applications that I feel really awesome. One of them, I remember that it's like one that basic from the vibration of a chips, of a plastic, from the chips, you can get the sound. So if you have a camera recording to a plastic of chips, of you can recover what is going on in that room. That I think it's a really cool application. That and there are a lot of papers about that. And also regarding to the ethics, I show another one that it was more controversial. That a couple years ago, I think it was Carnegie University, that released that basically from your router, you can create kind of a sonar, like Batman, let's say, and you can recover and you can predict the position of the people in the room based only on how your Wi-Fi router it's bouncing over the walls. And you basically you have converted all your phones on and all your routers into webcam cameras that you can spy everyone. And it's also and also this helped me to show that when we think about computer vision, everybody thinks only in image, like RGB image, you take a photo. And yes, this is like 90% of the cases, but at the end, everything can be converted into an image. Like you can convert to sound to an image, you can convert your Wi-Fi to an image, or for example, these autonomous vehicles, they use these lasers that, based on the bones, these leaders that can convert into an image. So I think, and I like to say that in the introduction, that I think like when I teach computer vision, it's like don't think that only webcam. Like you want to see how your computer can see the world in any aspect. Like no matter which kind of sensor, but at the end, what you are doing is kind of sensing the outside from your computer.
Right. What do we just think? I mean, the the need of avoiding the confusion of merging the idea of vision, human vision with computer vision.
Exactly, because computer is not limited to us. Like us, we can only see using our senses. No, computers can see in another ways. Like at the end, it's like computer sensing or whatever you want to call it. So I like to first introduce this a bit. Then when we move, it's like more from a simple neuron or a simple machine learning that probably has been already done in other subjects, but to refresh it to to a more complex networks like convolutional neural networks, transformers, or so on. And I like to finish with a more fun class, let's say, that it's more focusing in image generation, like how you have to train your models to generate your image, or to conditionate your models in order to, okay, I want this image to be like that. And I like to focus a lot more in the concepts that in the mathematicals behind it. Like for me, for example, I really love maths, and I can spend like 4 hours teaching maths to them if they are interested. But I think most of the cases, what I really saw in doing lecture is that if the student understand the concept, if he needs the maths, and if he's curious enough, he will search and he will manage to find the information. We live in a era that everybody has the information, so I'm more worried to understand the concept, to make them understand the concept. And if you have the concept, like you don't need to worry about all the maths behind it, because if you need it, you know where to find it, where to search it. Like I don't know, for example, I remember when I was studying in my high school, that the periodic table in chemistry, it was like, okay, but what do you need to remember? Like everybody, like I know I'm working in a chemistry department, and all the rooms have the chemist table behind me. It's like still nowadays I don't know where to find the elements. Like I'm working on checking, like then but again, this is my philosophy. But I think that uh, I I'm focused more that understand what they are doing. If you understand what you are doing, I'm happy. And then if you want the technical details, we can have a conversation, or you can search in internet, like or in the course you have also the mathematicals if you need it. But I'm more worried in.
That of course has changed a lot in time. This kind of memorization of a lot of data information is less and less maybe uh, central in learning, because we have a lot of resources that can help, and it's very important to learn to understand concepts in a way, yes, and the the idea of matching or bringing these concepts linking those to the applications that these tools have in real life has always been central in how we designed as an institution all our programs, starting from the bachelor to the masters. So we're really happy to hear how you help our students increase and improve their knowledge. I think, Alex, I don't really have anything more to ask you. It did really interesting.
Okay.
Nice. I hope that it will come out something interesting for students as well.